Hello, ladies and gentlemen. We are going to begin our lessons for the week. This is week 1 lessons, and it is about electrostatics or static electricity. We'll cover these subtopics: property of electric charges. That will help us to appreciate what we mean by electric charges. We can know electric charges better by their behavior and some properties that they exhibit. Then we'll also talk about materials, particularly about insulators and conductors. The insulators and conductors we are going to talk about here are with respect to electric charges. Remember, we also have insulators and conductors with respect to heat energy transfer. We are not focused on the heat energy transfer. We are going to focus our attention on insulators and conductors with respect to charges. Then we'll talk about the forces between charges. A very important law that we are going to consider will be Coulomb's law. Later on, we'll see how these forces can be visualized in a pattern that we call electric field. You should also realize that we do physics primarily because we want to understand the forces and the energy of objects, or the forces and energy that object possesses. So electric charges and their field also store a certain form of energy. We are going to see how we can quantify those energies and appreciate the energy around stored in an electric field. We have another quantity that will help us understand that one better. That is called potential. The energy stored in electric field, electric potential. The energy between 2 points will be potential differences. So we will learn about those ones. Then our focus will be for point charges and then charged conductors. We'll see about electric potential due to electric charges, point charges, and electric potential due to charged conductors. Even with charged conductors, we will focus only on parallel conductors. That will help us to understand capacitors in future. So let's move on to our first topic. That will be properties of electric charges. Okay, so the first topic will be properties of electric charges. This page you are seeing is coming from the reference textbook entitled Physics for Scientists and Engineers with Modern Physics by Selway and Birchner. You can turn to page 709 and you see this page. Now, what are the properties of electric charges? The first thing you need to know about electric charges is primarily about the two types. We have the positive charges and the negative charges. In fact, somebody may ask, why do we have positive charges and negative charges? Well, we know charges exist because of the properties and their behavior in scientific study. So we can't tell why. It's mainly it's by nature. But we've identified two different types. They are positive and negative charges. For now, you should just understand positive and negative charges with the electronic configuration of atoms. The electrons are negative charges and the protons are positive charges. This is what you need to understand for now. But the main property, the first property we are talking about now concerning charges will be the forces between the charges. If we have charges of the same type, then we expect them to repel each other. And if we have charges of different kinds, then we expect them to attract one another. So this is the first property you should know about charges. It's very fundamental and basic. Okay, So you should understand this important property very, very well. It's by nature. We can't explain why they behave that way, but we know this how charges do behave. So just keep this point in mind and see how we can apply it in whatever we are going to learn. Okay, so like charges do repel one another, and unlike charges attract one another. Positive charges and negative charges. If we have two positive charges, they will repel. They don't like one another. If we have a negative charge and a positive charge, then you expect a force of attraction between them. Okay, let's move on to the next property. It states that electric charge is always conserved. You've probably heard about the laws of conservation of mass and the laws of conservation of energy. Well, here is another law of conservation, or the principle of conservation of charges. Charges are neither destroyed nor created. So if we have a material and it is charged, then we have either excess protons in it, making it positively charged, or excess electrons, making it negatively charged. If they have equal protons and electrons, then the material will be neutrally charged. Thus, there will be no net charge on that material. What has happened to the charges in them? I mean, does it mean it doesn't have any electrons in them to make it negative charge, or does it mean it doesn't have a positive charge to make it positively charged? No. The positive charges are there, the negative charges are there, but then there are equal number of positive charges and negative charges. So together they neutralize each other, and it will appear as if the charges have destroyed one another. They've not destroyed one another. They are still there. They are conserved. But because one effect cancels the effect of the other, it might appear that they've cancelled one another. So charges are neither created nor destroyed. The number of charges or the quantity of charges in the universe is conserved, is the same. It's only that some quantities do neutralize one another to make it appear as if some of the charges have died or they've been eliminated. It doesn't happen that way. They are always conserved. We can bring them back to their original states by one way or the other. So get this point right. Charges are conserved. They are neither destroyed nor created. The third property that we would like to consider in this lecture will be the quantization of electric charges. What do we mean by quantization, or what do we mean by the term quantized? What it means is that charges can be divided until we get to the smallest value. We can't have any value smaller than this important value. So we have the fundamental, the smallest charge that you can have, which we call the fundamental charge to be 1.6 by 10 to the power negative 19 coulombs. This is the smallest charge that we can have. And if there are two of these charges, you just multiply this one by 2, and you get 3.2 by 10 to the power negative 19 coulombs. If we have 3, we should get this. In fact, if it is negative charge, then we include the negative signs. If not, then we may have to take off the negative signs to make it positive charges. Now, you can't have 2.5 by 10 to the power negative 19 coulombs. Why? Because if we have one charge, this is it. If we have two charges, then it will be 3.2. How are we going to have negative 2.5? That falls between here. We don't have any half charge. We don't have any quarter charge. We don't have any 1/6 charge. No, we have one charge to be this. Two charges put together will give you this. So we can have in between. This is what we mean by quantized. That means they jump in steps from 1.6 times 10 to the negative 19 coulombs. The next charge you can have will be twice this one, which will give us 3.2. We can't have any value in between. Likewise, we can't have any value in between here. It is either this, or that. If we have 3, you can find it yourself. If you have 3 charges, then it will be this one, 4 charges, and it will be this value multiplied by 4. So we can't have in between values. That's what we mean by quantization, or that charges are quantized. So that's the third property of charges that we need to appreciate. Robert Millikan discovered that electric charge always occurs as some integral multiple of a fundamental amount of charge, E. In modern terms, the electric charge, Q, is said to be quantized, where Q is the standard symbol used for charge. That is, electric charge exists as discrete packets, and we can write Q is equal to a certain integral number multiplied by the fundamental charge. I've shown you the fundamental charge, which is 1.6 by 10 to the power negative 19. So this one is an integer that has to be multiplied in order to get the charge here. Alright, so keep this point in mind. I'll give you some exercises for you to try.